I really feel very fortunate to have interacted with most of you and your companies through the Electric Mine Consortium. But as Adrian said, my name is Michelle Keegan, and I work at State of Play and State Advisory, where we run the Electric Mine Consortium, which is a group of over 20 members focused on accelerating progress towards a zero carbon mine. And I'm excited to be here. I think you've probably heard enough about the Electric Mine Consortium. You may think from earlier points, but I think there's a whole lot more detail and granularity, and really get into some more depth with the panel here, which I think is really exciting. So we're really here to discuss next level electrification, or effectively zero carbon operations, and where to from here. So given the companies that we have here today, what I think is really exciting about it is it brings both mining and services companies together. And I'm really keen to draw out perspectives based on that. Decarbonising isn't an easy challenge to solve for, and so our best chance really at success is centred on how we can collaborate together. So really excited to have Max here from Murray Engineering. We've got Nick from ABB, Brett from Oz, Martin from Evolution, and Rob from Goldfields. So with that, well, let's get straight into it. And I guess I'll ask each of you just to really introduce yourselves as we kind of get into the first question. So you can talk about who you are and where you come from. But really the first question I really want to get into is a bit more information or insight into the company targets that you have around emissions, your approach to deliver that with partners, suppliers, contractors, and like. And really keen, as you talk about that, what are some of the insights into the current progress you have at site? So maybe, Brett, do you want to kick off?
Very happy to kick off, Michelle. Thank you very much. Always good to go first, get it out of the way. So it's great to chat to you all this afternoon. My name's Brett. So I've worked for Oz Minerals for quite a long time now. My current role is as a technologist in Oz Minerals' transformation team, and our team is tasked with conceptualising what the mines of the future potentially look like for Oz Minerals. So it's a really exciting and interesting opportunity for me as a person with a technical background to have the opportunity to not be so focused on operations and the near term asset builds of Oz Minerals, but to really kind of cast my mind forward and think about what are the assets of Oz Minerals potentially looking like in 5, 10, 15 years time. Which is a really, really exciting and interesting place to live. So a little bit about Oz Minerals' targets and kind of where our focus areas are and how we're thinking about those targets at each of our assets currently. So Oz Minerals' priority is around eliminating Scope 1 emissions, and the target that we've set for ourselves is to be net zero with respect of Scope 1 by 2030. So it's a pretty ambitious target, and we're tackling this from quite a few different angles. And so let me give you a bit of a flavour for what that looks like. So at Prominent Hill, which is one of our operating assets in South Australia, we're in the process just at the moment of starting to build a shaft. So the intent is over the next couple of years we will eliminate truck haulage in our decline, and that will take quite a bit of diesel out of our operation as we move to being 100% lifting ore to the surface via shaft. At our other operating asset in South Australia, Carrapateena, the intent is to move to, in a similar way to Prominent Hill, to being 100% via conveyor decline. So at the moment we're a bit of a mix of conveyor and trucking. So as our block cave project ramps up over the next kind of 5 years, the intent is to move to 100% conveyor haulage. And again, that will take a lot of the diesel trucking out of the decline, and actually makes quite a significant impact from an emissions perspective. And So then we're going to have this tail of diesel equipment underground, both at Prominent Hill and Carrapateena. And what we're starting to do now is to work closely with our mining contractors and our and the OEMs as well to understand what the battery electric space looks like, with a view to undertaking some battery electric trials at both of those sites over the next couple of years. So the intent is to go fully battery electric over the next couple of years to tidy up that tail of emissions underground. So that's Carrapateena and Prominent Hill, which are our two operating assets. Another one that's really interesting that's worth chatting about is West Musgrave. So West Musgrave is a new project that has only just recently been approved for construction. It's in remote Western Australia, will be completely off-grid, and it's actually a renewables solution at West Musgrave that actually unlocked the project in the first place, given the cost competitiveness, if you like, of renewables now. So that was a real game changer, was to actually commit to a renewable solution at West Musgrave. So that'll be completely off-grid, powered by a combination of solar, wind, some battery storage, and a little tail of diesel. We're managing to get to about 70 to 80% renewables penetration at that project once we get it up and running. And the team at the moment are trying to work out how we're actually going to decarb that last kind of 20% from an emissions perspective. So there's some challenges there, but thinking about battery storage, other types of storage, using work in progress as a storage, so partially ground, partially produced product as a store of energy, hydrogen as another store of energy. In the pit, obviously, we'll be avoiding the use of diesel trucks, and so again, the team are looking at battery electric solutions and also trolley assist solutions, with a view to potentially being fully electric almost from day one if we can get there. The last thing I was going to mention for West Musgrave is some really innovative stuff that's happened around the way we've designed the processing plant. We've committed to using a vertical roller mills in the processing plant as opposed to a traditional SAG mill and ball mill circuit, and that has a few benefits. Firstly, about 20% less power compared to a traditional circuit using the VRMs. And one of the great things about the VRM, it's a dry mill that you can start and stop really, really quickly, as opposed to a traditional SAG mill, ball mill circuit that takes a long time to ramp up and can take quite a while to ramp down as well. And the intent is to actually have ground product between the grinding circuit and the flotation circuit as a store of energy, effectively. And so we'll be able to start and stop and ramp up and ramp down that mill in response to the availability of renewable energy, which I think is a really exciting opportunity for us, with the potential to help to push that renewables penetration even higher. So it's an interesting space that we're kind of delving into. So that's a bit of an overview, Michelle, in terms of where Oz Minerals is at.
It's a fantastic overview, and yeah, as you say, it is a very ambitious target, but really thinking quite innovatively across the whole value chain, and in particular, love the way you talk about different modes of storage. So I might hand over to Martin. I know you're doing something quite innovative in that area as well, but yeah, keen to hear more about the evolution story and your partnerships and approaches, as well as some early insights.
Certainly. I'll introduce myself first. Martin Sonogan, the Principal Mining Engineer, the Group Head Office, in the Transformation Effectiveness team. So we do a lot of things there, but as the name suggests, the transformational activities and projects are going to help us propel towards our goals. We have committed to a 2030 timeline for 30% reduction and a 2050 for net zero. So lots of options and technologies out there and lots of potential projects. We sort of break it down into three main parts. The near, the execute, the ones we need to accelerate for the next few years, and the ones we need to invest in for the longer term. So a bit of an example for some of those, our execute projects, the 2s and the 5% efficiencies in terms of plant electricity, fuel efficiency, the capital purchase of new equipment. We can buy those staged Tier 4 final engines that get a little bit more efficiency there. And that's the sort of things we can do right now. We know the technology is available and ready. We just need to spend the money and make it happen. In terms of accelerate, they're the other things that they're sort of coming into play now. We don't really have a full handle across what their capability is. The likes of that is our investment into an ST14, which if you look out that door there, that great big yellow thing, that electric scoop, we purchased one of those about a year ago, and that's been operating over in our Canadian Red Lake assets. And that's acting there as a bit of a trial to indicate and to understand what he can do for us and what we need to do in terms of our future planning and how to integrate into other assets. We're in a pretty good position, Evolution Mining. All of our assets are grid connected, so unlike Brett, who has a very isolated one out there, and it's not quite the same flexibility, we can have a very good, strong position. We can look at sourcing our power through renewable sources that are coming to the grid already. So very recently, about 2 weeks ago, we made a PPA, power purchase agreement, with AGL to source a large component of electricity for our Cal operation, which is based in regional New South Wales near Wagga Wagga. And that will be coming into effect over the next few years. And that's going to really help propel us towards our 2030 target of that 30% reduction just through the greening of electricity there, used at that site, which will then flow through into other sites later on. And the third one I spoke about in terms of investing, we know that the technology exists in some places for the underground equipment, but in terms of open pit equipment, it's a much larger challenge. The energy requirements are significantly larger. And that's stuff that's been worked on through a lot of the consortiums, the likes of Charge On Challenge. There's a lot of people coming together, the likes of us sitting here together, collaborating and working on that. But we know it's not there yet, but we want to invest in those sort of things. We're looking at different charging options, and one of the ones we're really interested in, we're taking an investment position, is the blue vein system there. So we see that as being a key enabler for dynamically powering our large mining trucks as we move forward into the future when it becomes commercially available. So yeah, a lot of different small timelines there, from the near to the mid to the far. That's how we're piecing it all together and make sure we can achieve our net zero commitments.
Is there anything you wanted to mention on the shaft as a mode of storage as well? The investigations you're looking at gravity as another path?
Yeah, that's another thing at the Ernest Henry operation there. We're sort of always looking, that's going to PFS for an extension there. We're just looking at what other options there includes, whether it's continue on with the shaft or other options there for internal conveying, electrical conveying, or whether it's other types of battery electric equipment there. But yeah, that's always something that's on the agendas when we're going to PFS studies.
All right, thanks, Martin. And I wouldn't mind understanding a little bit more about you, Rob, and Goldfields. I know whenever I've come across new technologies and talked to you about it, usually you've already jumped on it and you're busy trialling something. So yeah, there's a plethora of activity that you've got underway. I'd love to hear more about it.
Thanks, Michelle. Introduce myself first, Rob Derries. I'm the Unit Manager of Innovation Technology for the Australian region of Goldfields. So I'm involved in modernising our 4 mines that we have here in Australia. So modernising the mines in sort of 4 key pillars in our strategy, which is safety, which is very important to us, utilisation, decarbonisation, and then we're looking at modernisation and really just digitising. So modernising our operations, removing a lot of the waste out of our business. We're heavily working on mine operating systems, digitising a lot of the tasks that our people do on site, but decarbonisation is a huge thing for us. And we actually started that journey back in 2019, and our main driver for that was removing diesel particulate emissions from underground. And so we're heavily, I should probably take a step back. Goldfields is a South African gold miner. We've got 9 assets globally in 4 regions. 4 of those assets are in the Goldfields region in Western Australia. We've got a mixture of underground and open pit, but primarily underground. Our operations in Western Australia primarily underground. And so our big drive back in 2019, as I said, was to reduce the exposure to diesel particulate matter for our people underground. And that's when we started working with the OEMs like Sandvik and Epiroc and understanding what their reduced emission and zero emission roadmap was. And then in 2020, we started looking at our ESG targets. And so Goldfields' ESG targets are to reduce our carbon emissions by 2030 of 30% by 2030, And that's off our baseline in 2016. So when we look at our forecast, our production profile and our forecast for 2030, it's actually a reduction of 51% from where we were in 2016. So, and also very similar to Evolution, our target is zero emission by 2050. So a lot of the work that we've been doing to achieve our target of 30% by 2030 is around our power generation, which is actually 2/3 of our carbon emissions for our Australian region. And we're doing a lot of work, which a lot of people have probably already seen, the hybrid power station that we implemented at Agnew, which is solar, wind, gas and battery. That's currently around the 60-64% renewable, and we've got an expansion program to extend that up much higher. We're also doing solar at Granny Smith and battery. We've got another program where we're expanding our capability for renewables at Granny Smith. Gruyere, which is our open pit, we're doing the same thing there. We've had solar and battery in, which got commissioned this year. That's now getting expanded, and we've got an expansion project there to increase that. And St Ives will be our flagship for our, so currently Agnew's our flagship for renewables, but St Ives will be our flagship where we aim to be 98% renewables once we complete that project. Despite all of the work that we're doing with our power generation, we still need to reduce around 15 million litres of diesel out of our business to achieve our 2030 target. So that's a lot of diesel that we've got to remove out of our business. So there's a whole lot of work that we're doing. We're trialling battery electric equipment. So Sandvik did a presentation earlier. We're trialling their 50-tonne underground battery electric haul truck. We're trialling their 18-tonne battery electric loader, both of those being the first in Australia. We're working with 3ME Technologies to understand the battery electric IT, which Kyla presented and mentioned earlier. We're pretty fortunate to have the second one that they've developed. So we've got that underground at St Ives at the moment, understanding the technical readiness level of that. And again, we're not reducing a lot of diesel with that equipment, but we're making the working environment for our people a lot better and a lot cleaner. So there's work we're doing there. We're also partnered with Murray Engineering for the ultra-fast charge Toyota Land Cruiser retrofit. So we're working with the OEMs on their roadmap for reduced emission and so reduced diesel, whether that be diesel electric or other alternative fuel sources. We're also working with the OEMs on their battery electric roadmap and understanding that, but also working with other partners like Murray Engineering to understand where we can retrofit other equipment which the OEMs don't have a zero emission solution for in their roadmap. Also working with ABB with the work we're doing on our mine operating system, so we can actually reduce some of the waste out of our operations, especially with our haulage, and be a lot more efficient in our operations through the underground fleet management system that we're implementing at Granny Smith. That's going live at the end of this year, and we're then bringing that over into St Ives Invincible next year. So there's a whole lot of things we're doing, and I'm probably jumbling it all up into one big bucket. But we're doing a lot of work in material movement. So 49.7% of our carbon emissions is our underground haulage. 25% is our surface haulage, because we have a lot smaller surface haulage fleet. And then the other carbon emissions is made up of our ancillary equipment, surface loading, underground loading, and then a smaller percentage is our ancillary equipment as well. So we're also doing scoping studies on underground conveyor systems and overland conveyor systems as well. So we're looking at across the whole landscape on what we can implement to reduce our carbon emissions. It's going to be a bit of a slow burn. It's going to take us a while to understand it, which is why we're a part of the Electric Mine Consortium and why we're all sharing our learnings and sharing our trials. We can't all trial the same technology and the same equipment because it's not there. There's only a couple of these bits of gear around when we talk about battery electric equipment. So we're bringing all that information and all the data that we're capturing into the Electric Mine Consortium and sharing that data on the AWS data platform. So we can all harness that learning, and then also with the work that Brett is doing and the Oz team are doing, heading up the simulation, all the data that we're capturing with our trials, we're then feeding into the simulation work. So it really is beneficial for the industry. Was that enough?
Yeah. Well, I think you're just doing so much work, so it was always going to be long, and I think that's what's just really exciting, with everyone that's here. And And as you mentioned, given you've sucked up most of the electric vehicles that are available, it's it's great to be able to that's with your ambition and insight and kicking things off.
Yeah,
in
we
a
need to
number of
understand
years
it.
ago.
And that's why we're doing the trials, and I'm probably going off script now. That's probably your next question, Michelle. But the reason why we're doing these trials is so we can understand the technical readiness level of this equipment, and we can understand what it means to our operations and also what it means to our people. So what are the skills that we need to support this technology, maintain the technology, and also with the mine designs, how do we implement our learnings into our mine designs and into our greenfields mines as well?
Cool. Yeah, thank you. And I think, as you mentioned, there are so many things to learn, and really it is a big collaborative product development exercise in many ways as we start to learn more about the vehicles in the environment and then work with our partners on that. But as you've all indicated, we can't get there without our partners, so I'd love to hear more from Max and Nick about how are you working with mining companies to help support in the delivery of zero carbon emissions, and what are some of the projects that you've got going?
Thanks, Michelle. Hello, everyone. I'm Max Tong. I head up the innovation and technology at Murray Engineering. And one of our many projects, is sitting right out there on the show floor at the moment. It's the battery electric light vehicle that Goldfields are trying at the moment. My background has been in engineering, so I'll try not to get too much into the numbers today. But we are extremely privileged and grateful to be partnered and collaborating with Goldfields on such a significant project. For us, I think we're very passionate, and it's extremely overwhelming to be here listening to everyone talk about electrification, zero emissions, and decarbonization. I think many of you in the room today will remember when decarbonization meant clearing up the residue and cooked up throttle bodies in your smoky engines. And back then as well, zero emissions, impossible, impossible. How do we do that? But fast forward to today, we are excited about it. It's a buzzword, and solutions are now viable. We're putting it into practice. We are trialing it. We are driving it. We're breaking it. We're fixing it. We're getting going again, and pushing forward really. I think the other phrase that comes up a lot is diesel displacement. And again, looking back, it was a very polarizing topic, and it only meant that diesel displacement only meant how big your diesel engine was. But today, it's about reducing that and putting electrics into that space. So at Murray Engineering, I think we've always been innovative in doing what we do, as well as the Burncut Group. So I think a big shout out to our founders and directors, Steve Coughlin, Craig Lindsay, who's sitting in the room, Mark Coughlin as well. Senior leadership, they've always had the notion that we have to invest in innovation. We must change things, push things forward to make it better. And as contractors providing a value-added services and products, that's the only way that we can survive. And back to partnerships and collaboration, that's very, very important. So working closely with Goldfields from the start, we've defined the requirements, we've tried to understand what will and what won't work, try to debunk all the misconceptions about battery electric. And first and foremost, in this space, safe batteries has been our main focus, having something that is safe to use underground, not susceptible to thermal runaways, fire hazards, things like that. We focus a lot on that, and I'm happy to say that it's progressed well, and we're actually driving it today.
And you've got the full end-to-end charge infrastructure and vehicle as well?
Yes, that's right. I think in the electrification space, a total solution is quite important, and it's all very new to everyone. So the simpler it is to use, and the more interconnected, as was raised earlier today, that's very important.
And I really love the approach to light vehicle. I think we talk commonly amongst ourselves around the fact that while the emissions are limited in this area, it really is important area to help with the shift in mindset and help people learn about electrification and start to take on board new technologies and really hopefully drive the rest of the adoption across the site. So
yeah, absolutely. And on that point as well, we're at the stage where we're actually extracting data of fully battery electric vehicles. We can analyze that and then feed that into models and evaluate ourselves on how well we're doing.
That's great. And it's another important point around the fact that there's so much data off these machines available
Absolutely.
that we haven't had before. Cool. So I might hand over to you, Nick. I know that you're working, pretty widely across the industry. I'd love to hear more about the work that you're doing and your approach with mining companies.
Yeah, so thank you, Michelle. So my name is Nick Gresshoff. I head up mining at ABB here in Australia. Most of you know probably ABB is a technology provider. We've been around for over 130 years in mining. And I'm really happy to say that we're part of the innovation journey with all three of these companies that are sitting up here. Excuse me. I think it's key to think that we're not just about products. You can see our our charging solutions out there with the EpiRock truck. It's what you don't see is actually what's underneath the EpiRock truck. There is our drive systems and controllers and things like that are in these. We don't just work with EpiRock, we work with obviously all the large major OEMs, and I think that's the key part, that ABB is a global company providing technology into the global OEMs to really help drive the adoption of battery electric. I think, so that's from let's say from a product perspective, but then we also provide solutions. And I just want to say I'm very, very happy to hear Brett talk about the Prominent Hill shaft, because that's an ABB winder now. And it matches very well with what I said in my presentation as well. We have to have a fundamental shift, and actually I was speaking to Andrew Wibley, and this actually comes from him. It has to be a fundamental shift in our mentality on how actually we look at mining, and that is to go to conveyors, as an example, to go to hoisting solutions. Where we do use trucks, can we go to, can we use electric, etc., and things like that. And ABB is obviously just providing those solutions as well. But then again, if we look at Goldfields as well, we're delivering a lot of innovation in Australia, and actually that's probably one thing that I'm actually very proud of is in ABB. It's not just 130 years ago putting a motor on a winder. It's also about doing the digitalization projects that we're doing at Granny Smith for operational management, short interval control, and things like that. And they're being developed in Australia. The R&D is actually based here in Australia. So I think we're doing a lot of stuff from that side, not just providing our products, but also trying to lead in solutions and innovations. And then I think, we've all talked about it, but the EMC challenge that's recently happened, ABB's proud to support that, but we're also very proud to be in the Osmine Charge On Challenge and be a finalist, obviously, in that as well. More probably internationally, we are doing a lot of studies with trolley assist. That's seeming to be picking up quite considerably, and I know that I won't divulge too much, but we definitely are talking with other companies about that and what we can do on trolley type assist. And then we've got ABB has the first fully automated 600 kilowatt charging system, and we're obviously R&D and moving into megawatt type chargings, but fully automated, so there's no human involvement, etc. And there's trials being put in place in Canada as an example with companies like Meditech, which do conversions of diesel. And so it's go, let's put it that way, right?
It's a very, very wide portfolio of work that you talk about there, and it was fascinating to see proposal through the Electric Mine Consortium around a surface long-haul vehicle, I think, but as you point out, when we talk about decarbonisation, it's not just about electrifying a vehicle. Conveyors and shafts are all part of the solution as well. So we might shift pace a bit. I think we've heard now from the huge amount of activity happening across the guys represented here, but it's not without its challenges. And given the amount of work that you're doing, I'm sure you've faced many challenges. So really want to understand a little bit more about some of the barriers that you've seen in operations in the progress towards adoption of electric vehicles or electric fleet and the infrastructure around that. And how are you thinking about, or how you're already actively working on addressing those barriers? Might even kick back to you, Brett, to kick this off.
Full circle. No worries. So there's a few things I think that are worth chatting through around the challenges and the barriers. The first one obviously is probably the availability of the equipment, and we've already talked about that a little bit already. The example that I would give is that for the Carrapateena block cave, we need a 22-tonne battery electric loader, which currently doesn't exist. And so we're working closely with the OEMs to understand their timelines for when that gear is going to be available. And they're making some great progress, but still a few years to go yet. So it's understanding those timelines. Probably the next thing worth mentioning is the fact that we use contractors to do our mining at our operations, and typically they own the equipment. And so I think building the right partnerships and the right incentives and the right contract structures in a way that, and the right business models that allow a tripartite, three-way sharing of value to incentivise the uptake of this equipment is so important. And we're clearly working with our mining contractors at the same time to understand their drivers are perhaps slightly different to ours, and so it's just driving that alignment and understanding what their value drivers are, and working with them over time, as well as with the OEMs over time to come to a place where we're all aligned in terms of that value creation piece. The next one worth talking about is probably the kind of systems integration piece, I think. Lots of point solutions. We're looking at charging infrastructure in the EMC. There's the vehicles themselves, there's site power supply, there's storage solutions. They're all interconnected, and I think understanding how they all connect and interact and what the dependencies are is one of the next challenges. So one of the things that what we're contributing a lot to in the EMC is around simulation. So at the moment we're building an all singing, all dancing, hopefully, simulation of part of our Prominent Hill mine to understand how all of those systems interact, and what are the unexpected interactions and the unexpected events, and then using that capability to compare diesel solutions with electric solutions. Some of the other systems that I can think of as well, ventilation, the design of your drives, where do you put your charging infrastructure, what's your charging strategy, and so we're exploring the use of simulation to try to understand how all that kind of hangs together and to kind of point us in the right direction in terms of where we should go next with optimising these systems and what are the big questions that need to be answered. The last one I think that is kind of near and dear to my heart is around a little bit more in the disruptive space is new concepts of operation. So clearly we've got a paradigm currently that we're all trying to decarb, that involves particular mining methods and particular processing methods being integrated together. What I'm really curious about is how far can we push the sustainability story and including the decarb story with respect of the current paradigm, and can we achieve all those targets that we're setting for ourselves? And so some of the work that my team are doing in the transformation team at Oz Minerals is actually considering what does the mine of the future potentially look like for Oz Minerals, if we're thinking kind of the 10 to 15 year time frame, and what are the new paradigms potentially going to look like. So we're exploring things like mechanical cutting. So how do we get to a situation where we're not drilling and blasting and loading and hauling in the traditional sense, but a new concept of operations where we're relying completely on mechanical cutting and conveying to bring ore to surface, and doing away with the traditional paradigm. in mine recovery. So do we have to bring ore to the surface at all? Why don't we process it underground and just bring the final product to the surface? In situ recovery, so can we take advantage of some of the advances that are being made in the leaching and chemistry space to not build a mine at all? And if you play some thought experiments with some of those concepts, you can come to a situation where decarbonisation, very low water usage, very low footprint, very low no tailings, very low waste rock generation, are possible. So I'm kind of curiously exploring that space, Michelle. It's really exciting and really interesting as well. So.
Again, a really wide array of work that's happening there, and I think the further you push the ambition, the more that you can potentially achieve, but also the more you learn for the here and now. So
absolutely.
It's great. Martin, how about yourself? What are some of the barriers that you're seeing?
Sure, I'll just give two. I won't give as many as Brett. I wasn't leave any for Rob to talk about. But absolutely agree with everything Brett said, and we all experience the same sort of things. Two things I'll point out is capital efficiency. In a high-cost inflationary market, efficient use of capital is going to be paramount. So we look at the equipment we see out there, and high-performance batteries are pretty expensive, and very large high-performance batteries are really expensive. So it makes sense that this equipment's expensive. And of course, we need high adoption for these costs to come down, but we're in the early days of that. So it's really an understanding of, you get those paybacks on this equipment with very low operating costs, but there's a very high upfront cost there that needs to be understood there. So that can be quite a barrier there. Of course, to those who are in a tighter environment and need to control spending. And the second one, and everyone will definitely agree with me on this, is production parity. So we get this great equipment and it's powerful. The feedback from the operators over in Canada on that equipment, they love it, and that's really good to hear. I think the incentivisation or the drive from within, from people who want to see greening and want to see decarbonisation, really does sit as the centre of gravity to the whole journey. But they love it. But it's one of those things that it runs for however many hours it runs for, but then it needs to have a battery swap or a battery charge. So it's good equipment, but it just doesn't sit there in terms of production capability. And this is the things we're learning still at the moment. But of course, this is something that's evolving. Battery chemistry is always getting better. Systems are developing for how we can change batteries quicker. Dynamic charging, all these things are coming to play. But yeah, it's a very fast-moving space, but we're at the very beginning of that, is what I'd say. But yeah, getting to a time and place where production is on parity with what we have in terms of existing diesel fleet is going to be one of the big challenges.
Yeah, and both really, really good points. And I think that the more we trial, the more we learn, the more we look at product development and get towards our goals. So how about yourself, Rob? You've got so much going on.
Brett pretty much smashed it out of the park. I've been busy scratching my head thinking what I can talk about. I suppose not wanting to put a negative aspect on it, but some of the challenges that we are fearing and that we think we're going to be facing as we start scaling out this battery electric equipment, and if we're talking just on battery electric equipment and zero emission equipment, the first point that Brett spoke of correctly is the availability of the equipment. So we've got the 7th or 8th 50-tonne battery electric truck that has been built globally by Sandvik. We've got the second 18-tonne loader that's been built globally. So obviously the OEMs are working really hard to try and accelerate the manufacturing of this equipment. And they're building their manufacturing plants, so there's going to be an opportunity for them to scale, and I'm expecting, and to Martin's point as well, the capital cost and the operational cost is actually quite significantly higher than diesel equipment as well. So I'm expecting, and we're hoping, that there'll be a tipping point once we get an economy of scale. There's going to be a tipping point for capital cost and operational cost to be reasonable. Also in Australia, it's actually tough for us to compete with Canada, because Canada seem to have quite a lot of subsidies, and there's a lot of incentives within Canada for the mining companies to be implementing zero emission and reduced emission technology. We're not seeing that in Australia, and that's something that I think we actually need to be driving as an industry and working with the government to try and incentivise us adopting this technology and bringing this into our business. Because we all want to do it, and we're pushing the OEMs really hard, and it's not their fault. We're pushing them furiously hard to accelerate and bring this technology into the market faster. But I think the Australian government needs to be involved might be a bit of a bold statement, but I think the Australian government needs to assist us, or there needs to be mechanisms in place to assist the mining companies and the OEMs, because we want to manufacture in Australia as well. We don't want to be bringing equipment, all of the equipment and all of this technology from overseas. We want to do as much as we can within Australia. So there's one point. My second point is interoperability. So as we start scaling this equipment into our operations, we all have mixed fleet. We don't, unless most contractors will go with a specific OEM, but as a owner-operator, we have a whole mixed fleet of equipment through our operations. So for the charging, currently the OEMs have a mixed view and a mixed strategy on their charging standards, and we actually need to bring a standard charging standard, it's a weird thing to say, but a standard charging standard into the industry. So we need to follow a standard so we can have interoperable charging. And I'm sure Nick's got something to talk about that from ABB. But for us to expand our fleet and to have battery electric equipment in our underground operations, we need to have a Bowser, an electric charging Bowser that we can bring our equipment up to, plug it in and charge it, because we can't have different OEM charging infrastructure all through our mine. So that's probably my two key points.
Very, very good points. And to add on, and I might just hand to Nick just on that point, I think, we've almost got ahead of ourselves without a charging standard. So, can you kind of add to some of the barriers that you're seeing?
I think the first is the price is definitely a concern. So the technology, some of the stuff, it can be a big hurdle to put some of these things in place. And, compare it to a diesel truck. It could be 2 times as expensive as an example. But then there might be the infrastructure that's required as well. It's not just the truck itself. It's, a trolley line as an example. To put in a trolley line, you have to put in the infrastructure for the cables, the trolley, the power, and then, as I said earlier, if you're doing if it's an open pit mine and you've got a 300-ton haul truck, you're probably looking at about 4 megawatts per truck. So let's just say that you put 4 trucks on a trolley, that's, 16 megawatts of power. Let me ask, do any of your mines have 16 megawatts of spare power sitting there available?
Definitely not spare power. No.
So how are you going to...
fans off so we can charge our equipment?
Yeah. So how are you going to do that? Can someone, tell me, you're going to put more batteries in, you're going to have to put more solar, you're going to have to... And that's not going to come tomorrow, right? That's going to come... That was only 4 trucks, right? Just to let you know, right? And that's why what we're seeing is the adoption and the trial of 1, 2s, 3s, and 4s. But then there's that, it works with your current infrastructure, but maybe the infrastructure to adopt it fully would really actually need a rethink a little bit. So, and I'll separate that by being greenfield and brownfield. So what we are seeing is that on the greenfield side, people are starting to look at actually designing based on future decarb needs. And on the brownfield side, it's more like, how many more years do we have left of this mine? And if it's a 5 or 6 or 7 year mine life left, why would you invest, millions and millions of dollars in infrastructure? Maybe it's better just to let it peter out, right? So I think cost is absolutely, definitely a key thing. And it's also the cost of diesel, right? I mean, I've seen some mining companies, they're comparing electrical solutions to what the cost of diesel is. It's as simple as that for them. So it's just a straight economics decision. I think on the side of technology and having it available, I think definitely there is a shortage of components, and specifically, let's say, electronic components, which obviously where OEMs like us are working on to try to mitigate how long it takes to get some of these things, but there's also examples where I also counter-argue that and say, by the time you've built, sunk your shaft at Prominent Hill, we'd be ready to deliver the hoist, right? Because the time it takes to actually sink a shaft is probably longer than it takes us to build actually the hoists, right? We're not actually the long lead item. So there are, activities like that you could do, but then on the other hand, there's activities like, buying the trucks and things, which I know those OEMs have obviously got problems with. From the charging point, I actually totally agree. There's the CCS standards, and Max can probably talk tons about this, but there's the CCS standards, CCS1 and CCS2. Then there's I'm pretty sure the megawatt charging standard has not been probably fully, let's say, solidified. And like I said, ABB has a 600 kilowatt fast charger, and it's a very specific way of charging with a probe from Staubli. And again, that's not standardized, right? Like I'm pretty sure if you went across. So I do agree there definitely needs to be work done there. When it comes to ABB standard chargers, you'll see that we use the standard CCS ones and CCS2 type stuff. But yeah, that's probably, I agree with what they're saying, absolutely. But also I counter argue that sometimes it's about cost, right? Involvement and, you know, sinking a shaft at Oz Minerals is a very expensive probably exercise, right? It's not something that you make lightly. And there's you know, shareholders involved and other things. And we as a supplier, you can definitely feel that. And sometimes it's just as blatant as what's the cost of diesel versus what you have.
Yeah, a lot more thinking around those
Yep.
capital decisions. I might let you have the last say, Max, and I guess your vehicle in market is relatively new, but how are you starting to address some of the barriers that you're seeing?
Well, I think there are barriers that we have control over, and then there are challenges that are beyond our control. I think our engineering team, who haven't slept since 2018 probably, will have a handle on that. But what it is I think people and training is a very important part of rolling out new technology. Because being new, people are set in their ways out there. We have to train operators and change the mindset. And win hearts at the same time, I think. There are a lot of misconceptions and misperceptions about new technology, and we have to help to overcome that. Externally, though, in the manufacturing, supply chain, logistics, I think we've all been bitten hard with that. And for example, some difficulties with specialized EV connectors, interoperable, interfaces, things like that. One day you're buying, 1,000 pieces of those, and then, next week, some, automotive manufacturer has, bought the company and it's not available to you. So I think we have to remember that we are a relatively small EV, user group within a larger world of regular automotive users. And I think there's also a misconception that you can take a regular road EV, put it on the mine and expect it to work. And that, I think, is where we spend a lot of time with charging and the vehicle itself to know what works and doesn't work, and then design solutions around them, and then increase the reliability, maintainability. It's got to be serviceable in the field, so that's another challenge as well. So looking further down the line, and costs and sustainability has been mentioned. So initially, we looked at relifing our electric vehicles, because as you know, there's less wear and less parts to break. So we can actually transplant that into a second vehicle for a second life, therefore improving the asset costs and bringing down the total cost really and efficiency of the manufacture process. But now we're actually talking to Goldfields and others as well in the same mindset about relifing diesel vehicles in relatively good condition. So that's reusing an asset you already own, increasing its value, and then keep going with that. So I think that's an important discussion, dialogue that we all have to have and think about too.
Thank you. A lot of barriers there, but a lot of barriers you're starting to address and really facing head on, which is fantastic to see and hear about. But I think that's probably all the time that we've got. So yeah, great to have everyone here to be able to listen to all the work that these guys are doing. I think it's simply fantastic. It really is leadership in the industry. So thank you, everyone.
Thank you.